Quick little diag here. Got a 2006 Ford E350 for no start condition. So just gonna pull up the scanner, see if I have communication to anything on this one. So just gonna do an auto scan. This thing only has a couple modules because it's quite older now. But we could see the PCM's offline. We have the cluster and the ABS online. So I'm going to be focusing on this PCM for no communication. That's going to be what's causing this no start. Yeah, so this one doesn't communicate at all. I like to go through some of the other modules and just see if they actually communicate. Pull up like live data. See if I have any values there. Check the ABS module quick. I like to try and change some of the data PIDs, so like I'll look for like the brake pedal, something simple. Just press it, see if the data PID changes, so I know like live data is legit. So I got the battery disconnected real quick right here, and I'm just gonna do a resistance reading at the DLC. So I got my breakout box plugged into the DLC, got my meter leads in can high and can low, and we got 61 ohms, so that's going to be perfect for this, just showing that both terminating resistors are on the network, and we're not looking at like an open circuit condition across the can wires for this no communication issue. So here's a quick little diagram that I put together, just a redrawn. It's a little bit easier to view. Some of you guys commented down below saying you like these redrawn, so pretty much we just got the DLC here, we got can high and can low, and just all of the modules. Go back and splice in at this splice point right here, S228 and S269. So I'm pretty much just scoped in right here at 6 and 14, and we have a terminating resistor here in the instrument cluster and then one in the powertrain control module. So with the meter across these, I'm essentially reading these 120 ohm terminating resistors. So since I have that reading of 60, this network is complete. There's no open circuits in the wiring. If it was something like 120, then there'd be an issue, and then I'd be looking at this diag a little bit differently. But for now, this seems good, and we're going to move on to just hooking up the PicoScope here right into the breakout box. I'm just going to scope can high, can low. Want to see what the waveform looks like here. This looks like a nice healthy waveform here. I finally started using Pico 7. I've been on 6 for so long, so here we go. We're into a screen recording now. And again, when I screen record, these colors kind of get clipped, so it doesn't look like that in person. But this looks like a nice healthy waveform here. I don't see any issues with this. The voltages are where they should be. So I'm just going to pause it here, pull some rulers down just to show some measurements. So we got 3.5 on the top, got 2.5 in the middle, and then on the other trace, like 1.47. So we're like within perfect voltage ranges for can high and low. Here's a little zoomed in view of what this looks like. Again, looking like a normal can waveform to me. Nothing that I really see wrong with this, but just a good little view if you've never seen can. So here's the last diagram. This is the power circuit for the powertrain control module. We got 2 fuses on the top, a 10 amp and a 20 amp, and then we got 4 grounds on the bottom. So I'm going to go over to the powertrain control module just with a headlight bulb and my terminal kit, and we're just going to test powers and grounds at the module and see what that looks like. So I got my headlight bulb here and some terminal leads. Just going to test across powers and grounds, make sure it lights the bulb. So we're testing across pins 35 and 36, and neither one of them are lighting the bulb. So that looks like that's what the issue is going to be here. I like to go back and just verify that my bulb is good. Now we're just going to test the ground circuit, make sure there's no issues. Terminal tension feels good. So all of these seem to check out pretty good. So here's just a snippet of what the factory diagram looked like here. Definitely a lot more going on, so that was one of the reasons why I did the redrawn on it, just to simplify. So last thing I'm going to do over here is just go to the fuse and see if we have power at the fuse. And you can see we're only lighting one side of the fuse. The other side isn't lighting. Here's a good fuse. Just test the other ones. But this one fuse for the PCM, looks like we have a blown fuse here. So we got a new fuse put in, and you can see now we got communication restored to the powertrain control module. So our 3 CAN modules are online. We do have some fault codes in the powertrain control module now. See if any of them clear. Looks like it did clear. Now we're just going to see if it starts. Looks like this one starts and runs. We got communication. Looks like we do have 2 fault codes in the ECM though. So it looks like that air temp sensor came back. So I usually like to use my amp clamp just to see how much current the circuit is drawing, but unfortunately my amp clamp did break, so I didn't really have any way of checking that. But I hope you guys enjoyed this little video. Let me know what you think down in the comments below, and I'll catch you guys on the next one.